Hi students, I decided to post a video for the spring of 2015. You already have the answers to the questions, but I thought that I would show you the work and also talk through the work and show you the steps. For question number 1 on this particular practice test, if you're looking at your copy, it said evaluate the indefinite interval below. Sine of 4x divided by 1 plus cosine of 4x quantity cubed in the denominator. Simplify as much as possible and show as many steps as possible. With the u substitution, let u be 1 plus cosine 4x and then find du. Please show the complete change from a problem in x to a problem in u before giving the antiderivative. Remember how I showed you u substitution in class. I would like for the final answer to have no negative exponents. So that's going to be crucial in the final answer. U substitution has already been started for you. I did tell you to let u be 1 plus the cosine of 4x. And then we need to find du dx. And then, obviously, we need to find du. I often do this is provide a box for you to fill in the rest of the information. You are going to have to use the chain rule for taking derivatives. Here is the chain rule. The chain rule says if, and this is just a side note, okay? But this is calculus 1. If you have a composite function f of g of x, and that's what we have here, a composite function within a function, the derivative of that by chain rule is the derivative of the outside function evaluated at the inside function times the derivative of the inside function. Chain rule. So if you're looking at this, you're taking the derivative of u with respect to x. The derivative of 1 is 0, so we have to figure out the derivative of cosine 4x. The inside is 4x, and the overall outside is just cosine. So the derivative, again, the derivative of 1 is 0, and then we have to think. Derivative of outside evaluated at inside times the derivative of the inside. The derivative of the outside, the derivative of cosine is negative sine. So the derivative of the outside and then evaluated at the inside times the derivative of the inside, which is just 4. This derivative will simplify to negative 4 sine of 4x. Therefore, du is negative 4 sine of 4x dx. I am going to use this and the fact that u is 1 plus the cosine of 4x to change my problem in x to a problem in u. To do that, I'm going to rewrite the problem. I think it's important. 1 plus the cosine of 4x quantity cubed in the denominator. I am going to rewrite it, which does not change the problem, as 1 divided by 1 plus cosine of 4x quantity cubed times sine of 4x. And to complete the substitution, I would need a negative 4 on the inside, and therefore a negative 1/4 on the outside. So you could take a different color of pen, or you could completely write a different step if you needed to, another step. I am going to, at this step, go ahead and put in the negative 4 I need on the inside, but I have to take it away at the same time. Negative 1/4 times negative 4 is 1, and I have not changed the problem. But that will allow me to change over to u. So this will be 1 over u cubed du. Negative 4 sine of 4x dx is all of your du, which is taking its place, they're equivalent. And then in the denominator, this would be u quantity cubed. To finish this process, before you can use your integration rule, you'll need to take the u cubed in the denominator and move it to the numerator by making the exponent negative. And then you're ready to integrate. So I'm dropping my integral symbol, and the box is waiting for my antiderivative. So u to the negative 3 plus 1, divided by negative 3 plus 1, and that's going to be u to the negative 2 divided by negative 2. You can simplify. I hope that you see that that's a negative 1/4 times a negative 1/2 if you pull the negative 1/2 out, and that gives you positive 1 over 8. So 1/8 u to the negative 2 plus c, which is also the same as 1 divided by 8u squared. All of this is algebra. And if you remember, the directions say to get the final answer with no negative exponents, which leads me to the final answer. I'm going to draw an arrow up above so I don't have to go to the next page. I'm going to go back and substitute in for u, and that's going to give me my final answer, and I'm done. So that is going to be 1 divided by 8, brackets, 1 plus the cosine of 4x, quantity squared, plus c. Final answer, no negative exponents. And I hope and pray if you had any questions about that, it did clear that up for you. I know that that was a rather complicated u substitution problem, but I promise you it is covered in Calculus 1. If you notice when on my answer sheet, it's very important that that 8 is in the denominator. Some students do give me the final answer as 1 divided by 8 plus, that would not be correct if they did that. I was thinking in the past, I've had students say this is 8 plus 8 cosine 4x quantity squared, which since this is quantity squared, you cannot just distribute the 8 to both of those. If it was just 1 plus cosine 4x, you could distribute the 8 to both of these and leave the final answer that way. So that's one of the main reasons we leave the 1 over 8 or the 8 on the outside here. So this is probably the best way to give the most simplified answer, no negative exponents. Now we're going to move to question number 2. Question number 2, if you remember, is very similar to a question we did on the practice test from the fall of 2011. It says, with a combination of algebra and geometry, please solve the following definite integral. And the limits will go from 0 to 4. Evaluate by using a combination of algebra and geometry to solve the following definite integral. Please give your final answer as an exact answer containing pi. Graphing the geometric figure is not mandatory, but it would help me to see where you could be making possible errors. Hence, separate the two definite integrals. So I would recommend that you do this. 0 to 4 of just your 5 minus 0 to 4 square root of 16 minus x squared. This one is algebra and this one is geometry. In Calculus 1 going into Calculus 2, it's not an algebraic way to solve this particular definite integral, you would need geometry. It was not mandatory to graph it, but this is the circle that has radius of 4. So if you think about negative 4 and negative 4, and we only want to see the graph from x equals 0 to x equals 4, the graph is a quarter of a circle. I don't have to have this as part of your work, but just remember this circle, x squared plus y squared is 16. So, and 16 is expressed as 4 squared, so the radius is 4. And if you solve for y, you get y squared is 16 minus x squared, and then if you take plus and minus, you have the upper semicircle and the lower semicircle to make the entire circle. But I only need to see the graph from 0 to 4. This one, algebra, the antiderivative of 5x to the understood 0 power is just going to be 5x. And you're going to evaluate from 0 to 4. So the antiderivative of 5 is 5x. And then this one, using the geometry formula, 1/4 pi r squared. And in this case, the radius is 4 for this circle. If you perform the fundamental theorem of calculus, this is 5 times 4 minus 5 times 0. And this is going to be 1/4 times pi times 16. This is going to be 20, and this is going to equal 4 pi. Final answer containing pi. Again, I pray that going over this one, number 2, will help you understand this process just a little bit better. So, question number 3. This particular question was not on the practice test fall 2011. I had a different question for number 3. But the directions say, solve the indefinite integral below, show as many steps as possible, which includes u substitution. Please share or place your choice for u in the box, and then give me du and x, and then show all of the work. When you have a problem like this or something very similar to this one, what you're going to want to do to start off with u substitution is let it be the expression under the radical. And then when you find the derivative of u with respect to x, I hope you see that it's just negative 1. So du is a negative dx. I'll need this, and I'll need this. And I'll need one more thing. I will need to know what x is equal to. If u is 2 minus x, if I solve this for x, I add x to both sides and then subtract u. That means x is 2 minus u. And then you're ready to show substitution. So I'm going to bring down the next step. If you notice, I need a negative dx, and I don't have a negative 1 times dx. So I'm going to put a negative 1 inside and a negative 1 on the outside. And then make my substitutions. In place of x, I put 2 minus u, and parentheses are very important. Under the radical, in place of 2 minus x, I put its equivalent of u, and then negative dx is the same as du. You notice I was in x here all the way, x here all the way, and then with u sub, correct formation and notation, I'm only in u. In one single step, you cannot be in both u and x at the same time, and I see that all of the time, and I will count off. So please be very careful with that. You will need to change this square root of u to the 1/2 and distribute. And that's distributed to the 2 and the negative u. So that becomes 2u minus u to the 3/2. Remember, when you have like bases, like a u and a u, you add their exponents when you multiply. So 1 plus 1/2 is 1.5 or 3/2. And then this is how I would recommend you go about finding the antiderivative. The negative outside, a huge set of brackets, and plus c. And for 2u, that would be 2u to the 1 plus 1 over 1 plus 1. And then u to the 3/2, that would be minus u to the 3/2 plus 1 over 3/2 plus 1. Quick way to find the antiderivative with the basic rule. Let me correct myself before I go too much further. I noticed that here, 2 times u to the 1/2, I wrote 2u. So that's really 2u to the 1/2. And then when I distribute here, u times u to the 1/2 is u to the 3/2. So I apologize for that. So in finding the antiderivative, this should be 1/2 plus 1 and 1/2 plus 1. Continuing the process, this is going to be 2 times u to the 3/2 divided by 3/2 minus u to the 5/2 divided by 5/2 plus c. I hope you know if you divide by a fraction like 3/2, you're multiplying by 2/3. If you divide by 5/2, you're multiplying by 2/5. And notice how the negative is still on the overall outside, so 2 times 2/3, u to the 3/2 minus 2/5, u to the 5/2 plus c. I can go ahead and distribute the negative at this time. This is going to be 4/3, so that's a negative 4/3, u to the 3/2. And then a negative times a negative is a positive 2/5, u to the 5/2 plus c. You could rewrite it as, and it's completely up to you, 2/5 u to the 5/2 minus 4/3 u to the 3/2 plus c. With the theory that we know as math students, the exponents are supposed to decrease. 5/2 is 2.5 and 3/2 is 1.5. It's not necessary to rewrite it. Now you go back and substitute in for u, and this would be your final answer. 2/5 parentheses 2 minus x to the 5/2 minus 4/3 2 minus x to the 3/2 plus c. Final answer. And that would be how you would solve a problem very similar to this one. And let me tell you what I mean by that. If you notice, the original problem is x times the square root of 2 minus x. Different versions of that same problem. And I want to leave my final answer here. But I could give you a similar problem. I could ask you to find the antiderivative for x, square root of 5 minus x. I could ask you for x, square root of 7 minus x. I could ask you for the antiderivative of x, square root of 3 minus x. and so on and so on. And you would follow a very similar pattern to answer all three of those questions. So don't forget the method of u is 2 minus x, the expression under the radical, and then du dx, and then you'll need to also solve for x with a problem like this one by using this equation, and then make all your substitutions. So I'm hoping that that cleared question number 3. Question number 4 is the average value problem, or the mean value theorem. And the function is 3x minus 2 on the closed interval (1, 3). And the question says, give the average value f of c, give the exact answer. Please give me the correct formula before showing the substitution process. And then on the last part of it, I will ask for the value of c. I'm not going to graph this line, but this is a line, and I would only need to see the graph from 1 to 3. Remember what the mean value theorem says, that if I want to talk about the area under the curve that I'm giving from A to B, that's equal to the area of a rectangle that is formed at a special point on the curve CF of C. So this is the area under the curve, and this is the area of the rectangle, and they are equivalent. For this problem, it would be 1 to 3, 3x minus 2 dx is equal to f of c times b minus a, and you would go from there. F of c would be the height of the rectangle that's formed, and b minus a, or 3 minus 1, is the base or the width of the rectangle that is formed. And height times the base, or base times height, length times width, would give you the area of the rectangle. So there's a very special point on y equals 3x minus 2 called CF of c. There's at least one number c on the x-axis such that you can form a rectangle at the point CF of c. And we need to know both. We need to know f of c as the height, and then find c on the interval or x-axis. And that point defines the rectangle, and the area of the rectangle is equal to the area under the curve. Now remember the formula. If I divide both sides of this equation by 2, I would have the formula for average value, but let me go ahead and rewrite that without plugging in the given function. And that would leave us with 1 over 3 minus 1, 1 to 3, 3x minus 2 dx. So if I'm dividing both sides by 2, I'm also multiplying both sides by a half to isolate the f of x and solve for average value. That's algebra. And then that's the next step. And technically you're ready to solve the integral in terms of finding its antiderivative. The antiderivative of 3x should be 3/2 x squared, and the antiderivative of -2 is a -2x. And I just used the basic power rules there, but I did skip over the steps of showing you the addition, the exponent of 1 plus 1 divided by 1 plus 1. That's where I got the 3/2 x squared. And then obviously this is x to the 0. So x to the 0 plus 1 divided by 0 plus 1 to simplify down to the antiderivative. For this one, I recommend leaving the 1/2 outside, and then fundamental theorem of calculus. First, substitute in your 3, and I'll put a big set of brackets around that, and then substitute in your 1. And you need to continue to carry the algebra out throughout the problem, and that's 1/2. And you just keep bringing it down. That's going to be 3/2 times 9, which is 27 halves, minus 6. And this one is going to be 3 halves minus 2. You can see that your LCD is going to be 2 because of these fractions. So you could go ahead and change everything over to have a denominator of 2. 27 halves is good, but this is going to be minus 12 halves because that's 6. And then minus 3 halves minus 4 halves. Order of operations, please excuse my dear Aunt Sally. These brackets and parentheses are very important with algebra. 27 halves minus 12 halves is going to be what? Is it 15 halves? It's been a long day. So 27 minus 12, 15 halves. And then that's minus, and I do believe that's going to be a negative 1 half. So that's 15 halves plus a half. So 1 half times basically 16 halves. And that gives me 1 half times 8, or 16 over 4. And the final answer, oh, that's beautiful. The average value, or the height of the rectangle, is 4. F of C is equal to 4. And then we need to find C, which is on the x-axis. And then again, this point forms the rectangle. So we need C. We know the height is now 4. And this point is on the graph of this line, so that I can draw out a rectangle, and the area of that rectangle is the area under the curve. So, to solve for C, you have to remember the function. And that means that f of C is also 3c minus 2. And we've just proven that f of C is 4. And then I solve for C. Add 2. And then divide by 3. C is equal to 2. That's also another beautiful result there. Do not forget that you will need to make sure that your choice for C is in your closed interval AB. If you remember, this closed interval was 1 to 3. Definitely in the open interval or the closed. So 2 is definitely in your interval there. So check that's your value of C. I could graph this function and I could put in the boundaries, x equals 1, x equals 3. I could plot the point we know now, C is 2 and f of C or f of 2 is 4. I could show you the rectangle and show you how the area of the rectangle equals the area under the curve. We did all of that in class, but if you want to see that, it's great to do. I just recommend graph paper. That'll give you a better representation of the true theorem here. Now, last question is number 5. Finding the lower sum, upper sum, and possibly the exact area for this function. The area under the curve. And it's on the closed interval 3, 6. I only wish for you to use 4 rectangles. So it says, use the rectangle method to approximate the area under the curve, or the exact area. On the closed interval 3 to 6, use 4 rectangles. We're going to do some of the preliminary steps. The first one is the width. So b minus a divided by n is going to be 6 minus 3 divided by 4, which is 3/4, and I hope you know that's 0.75. And then you have to be able to tell if the function's increasing or decreasing. the function is increasing. All you have to do, if you don't want to graph that by hand, remember you can go to y equals and put in the square root of x minus 2 plus 1. And you can graph it to see that it is indeed increasing from left to right. You really only want to see the part of the graph between 3 and 6, so you could go to second table set to set up your window. Tell the table to start at 3 and increment the table to be 3 divided by 4 or 0.75, and then go back to table, which is second graph, and if you enlarge, you'll see that the functional value at x equals 3 is 2, and the functional value at x equals 6 is 3, and then we have all of these other values which will end up being the heights of our 4 rectangles. So this is great. This is with the lower sum, since the function's increasing, we are going to use, and you have to think about this, the endpoints, and we do need to figure out the endpoints, which would be the next step, the subintervals on the x-axis. We are going to use the right-hand endpoints for this, when it's the lower sum, and when it's upper sum, because the function's increasing, we're going to use the left. So subintervals. 3, comma, 3 plus 3/4. That's 3.75 is also 15/4. And then 15/4 plus another 3/4 is 18/4, which is 9/2. 18/4 or 9/2 plus another 3/4 is 21/4. And then 21/4 plus another 3/4 is 24/4, which ends up being 6. So I'm just adding 3/4 each time. I did express these endpoints as fractions, but do keep in mind it's the same as 3, 3.75, 3.75, 4.5, 4.5, 5.25, and 5.25, 6, if you wanted to see those as decimals. And again, that's all on the x-axis. All of these are your left, and all of these are your right. And let me say here, before I go further, with the functions increasing and you want to find the lower sum, use the left-hand endpoints. When the function's increasing and you want to find the upper sum, use the right. Sorry, I switched those around. Usually I graph the function on the interval 3 to 6, and I even graph all 4 rectangles under the curve and above the curve, and then that gives me a great visual of which endpoints I need to use to construct. So I would highly recommend that if you have time, but you may not have time to do that on the test. You may just have to memorize when the function's increasing from left to right, lower sum left, upper sum right, which I didn't do a great job of that. It was not until I wrote out my subintervals that I realized that, so I apologize for that switch. So let's start with the next thing that we need is our XY chart. And that's going to be 3 15/4 or 3.75, 9/2 or 4.5, 21/4, and then 6. And we already have that on our calculator. I do believe I said if you have to round the heights or the y values, round to 4 places accurately. Therefore, I will round, and it looks like they're already given to 4 places. But if you're not using a calculator to find your table, you're going to have to take the time to plug every single value in for your x to determine those y values. And then that's when some of you will have to round. When x is 3, y is 2. When x is 6, y is 3. When x is 15/4, so 3.75, 2.3229. When x is 9/2, or 4.5, it's 2.5811. And then when x is 5.25, or 21/4, it's 2.8028. Again, for the lower sum, we want to take the left-hand endpoints to form our rectangles and use those heights. For the upper sum, we want to use the right-hand endpoints there. Let me do a quick sketch. I was not intending to do so. I don't think it's on my original answer key, if you're following the original answer key. I'm going to increment 1, 2, 3, 4, 5, 6. Oh, excuse me. Let me start over. I cannot increment it like that. I need my increments to be in increments of 3/4. Let's start again. So f of x is the square root of x minus 2 plus 1. And again, I have my xy. I'm just interested 3, 15/4, 9/2, 21/4, and 6. And I'm just interested in those values. I'm just recopying from the other sheet. And those are the values. Let me do a much better job, please, of graphing. I'm not going to use graph papers, so it still may have some issues. And I think what I'll do is just concentrate on drawing the rectangles for the lower sum, which are below the curve. I'm going to use something called a change of scale symbol, if you've never used one of those, which means I really don't want to start at 0. I'm going to come over a little bit after my change of scale symbol, and I'm going to make my mark of 3. And then I need 4 equal increments, so I'll do 1, 2, 3, and 4. So the next one is going to be 15/4, and then 9/2, and then 21/4, and then 6 on the x-axis. Those are my x values that determine my 4 different sub-intervals, which will determine my rectangles. I want to plot my y values, and to get a really good graph of this, I know that my y values, the largest is 3, so I could actually, I don't need a change of scale. I could just do 1, 2, and 3. So when x is 3, I have 2. When x is 6, I have 3. So this is the point 6, 3, and this is the point 3, 2. Labeling the points 3, 2, 6, 3. When it's 15/4, it's about a 2.3. And then here's a 2.5. We're going to need that 2.5 to help us here. And what I'm going to do is, because I know this can get kind of close, I am going to just go ahead and connect the dots. I hope you know what this type of function looks like. It's coming from the parent function square root of x, and the square root of x looks like this. The domain is the set of all x such that x is greater than or equal to 0, and the range is the set of all y such that y is greater than or equal to 0. So the graph only occurs in the first quadrant. This is a horizontal shift to the right 2 units and a vertical shift up 1 unit. So since I did my change of scale, it's going to be hard to show you where this starts and then the shift up because I did the change of scale on the x-axis. But if you wanted to see again the graph of the whole thing very quickly before I just graph a portion of it. And if you really want to see, you know, what's going on, you could zoom in. And you could see that the place where this starts, where you have your horizontal shift and your vertical shift, is going to be the point 2, 1 is where it starts. And then you would see that the domain is going to be all x values greater than or equal to 2. The range is going to be all y values greater than or equal to 1 because of the shifts. And that's a horizontal shift to the right and a vertical shift up. So 2 to the right and 1 up, which will change the domain and range of my parent function, which originally started as greater than or equal to 0. Therefore, I'm going to do this because I know it's a curve and it's not a straight line. Don't use a ruler and make that look like a straight line there. And then I want to think about drawing in my rectangles underneath. I want to do my left-hand endpoints for my lower sum. My first left-hand endpoint is 3. And so this value of 2 is going to determine my height. So I come over and I come down, a ruler would be nice, at my next left-hand endpoint. My next left-hand endpoint is 15/4, and that value is 2.3229. So that's here. Again, I am going to come across and come down. Do that one. My next left-hand endpoint is 9/4, and the functional, 9/2. The functional value at 9/2 is 2.5811. So I'm going to come up to meet the curve. I'm going to come across and come down. There's my third rectangle. The last left-hand endpoint is 21/4, and the functional value or the y value on the curve is 2.8028. So with that, I would come up here and I would come across. Again, graph paper is much better. And there's area 1, area 2, area 3, and area 4 for the lower sum. So this value is 3,2. The height of the first rectangle is 2. And then the height of the last rectangle here, if you remember, that was the point 21/4, comma 2.8028. So here we go as far as lower sum. Lower sum is going to be the common base of 3/4. And then I'm going to begin to add up my heights. The height of my first rectangle under the curve is 2. The height of my next rectangle under the curve, which is determined here, is 2.3229. The height of the next one is 2.5811, and the last one is 2.8028. So what I'm doing is I'm adding up the first 4 y values there for the area or the height of my 4 rectangles under the curve. And what you end up with for your lower sum, you'll want to put this in your calculator, and keep in mind my heights are rounded to 4 decimal places. And so you also better round your heights to 4 decimal places, because I should see when you add those up, this number, 9.7068 times 3/4 is 7.2801. There's my lower sum. Lower sum. Now the upper sum, I'll just come here. I'm not going to take the time to draw the rectangles for the upper sum but we do use the right-hand endpoint since the function is increasing. So this is the first right-hand endpoint on the x-axis, and second right-hand endpoint, the third and the fourth right-hand endpoint. And I know what happens at those particular right-hand endpoints. In regards to my XY chart, this is my first right-hand endpoint on the x-axis, and this is the height of my first rectangle above the curve. And this is the height of my last rectangle above the curve. So I would do the height of the first one at my first right-hand endpoint, 2.3229, plus 2.5811, plus 2.8028, plus 3. The number that you should see when you add up all of your heights will be 10.7068. When you multiply by 3/4, you get 8.0301. I'll box it and put a check. So there's your upper sum. I could give you a little bit of a visual here. If you are determining the upper sum or the rectangles above, I can try to use another color to show you that, and I'll just show you a little bit. I hope I haven't completely destroyed my graph, but using the first right-hand endpoint of 15/4 and the height, that rectangle would look like this above the curve in orange. I'm not sure if you can, yeah, there you go. And then using my next right-hand endpoint of 9/2, that would be here. And then again, I'd come across this way and come down. My next right-hand endpoint of 21/4 would be here. I'd come across and come down. And then my last right-hand endpoint of 6 would be here. I'd come across and come down. So those are the rectangles above the curve. And then those would be the heights at those right-hand endpoints. And I hope this helps you, again, with, again, area under the curve, using the rectangles to find the lower sum and the upper sum. And the lower sum, if you remember, is 7.2801 less than the exact area, less than 8.0301. The exact area is 23/3 or 7.6 repeated. Exact area. The way that you would set up the exact area would be as follows. That's the last question. Yeah. And you are able to do this now in the calculus, as of the end of calculus 1. I recommend that you rewrite it as x minus 2 to the 1/2 power plus 1. You'll need u substitution. U is x minus 2. Du dx is 1, so du equals dx. You'll need new limits. X is 3, so u is 3 minus 2, which is 1. X is 6, so u is 6 minus 2, which is 4. So instead of going from 3 to 6, it's going to go from 1 to 4. And you're basically ready to change over. I don't have to put a real number or number inside and then it's reciprocal on the outside. I don't need a form of 1. So the new limit's 1 to 4. In place of x minus 2, I say u to the 1/2 plus 1, and du is equal to dx. So there you go. Changing over to u with my new limits. And then you find the antiderivative. U to the 1/2 plus 1 divided by 1/2 plus 1 plus an understood u to the 0 power. The antiderivative of 1 is just going to be u. Now I'll show you. And then limits. When it's a definite integral like this and you're doing u substitution, there's no need to go back to x at all. You can stay in u if you have new limits. Find the antiderivative in terms of u and use your new limits, and you're done. You're finding that numerical answer there. So that's going to be u to the 3 halves divided by 3 halves plus just u. 1 to 4. 1 to 4. That's going to be 2/3 u to the 3 halves plus u. 1 to 4. You'll first substitute in 4. So it's going to be 2/3, 4 to the 3 halves, plus 4, minus, and then you'll substitute in 1. 2/3 times 1 to the 3 halves, plus 1. And go about finding the answers. 4 to the 3 halves is like taking the square root of 4, as indicated by the 2 here. The square root of 4, and then cubing it. In other words, I'll just draw an arrow. 4 to the 3 halves is the square root of 4 quantity cubed. And the square root of 4 is 2. 2 cubed is 8. And then 8 times 2/3 is 16/3. So 16/3 plus 4 minus, and that's going to be 2/3 plus 1. I will need my LCD of 3. So 16/3 plus 12/3. Minus 2/3 plus 3/3. 16/3 plus 12/3 is 28/3. And then 2/3 plus 3/3 is 5/3. And that's going to give you 23/3. And that is equal to 7.6 repeating. Exact answer as a fraction, exact answer as a repeating decimal. So I think that's another great example of Calculus 1 that was u sub as a definite integral. And again, I don't go back to x. Some students do. They will go back to x and use which you better use, if you go back to x, you better use your original limits of 3 to 6 before you show the fundamental theorem of calculus. I stay in u because I found my new limits in terms of u, and I never go back to x because it's a definite integral. I just work it out and find my final numerical answer. I hope that this video has been helpful, and I hope that you do very well on the test on Friday. Please do take the time to review. Again,